everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have an interesting GitLab report, the Powerdir macOS vuln, stealing Google Drive OAuth tokens from Dropbox, and more. Quick reminder that next week will be the last week of doing the podcast for a few months. We will be returning after the summer break. Don't have a date set yet exactly for that, but we'll have one tomorrow and next week for you guys. And we'll also send out notifications about that as well. Also, a reminder that we're going to be covering 2 more talks from OffensiveCon and a watch party stream this Friday at 6 p.m. Eastern, 3 p.m. Pacific on YouTube. For those who missed the one we did last week, the VOD is already up on YouTube. It went up basically as soon as the stream was done. That is one of the nice things about streaming on YouTube. Last week we covered Counter-Strike Global Offsets, which was a talk about exploiting Source Engine. And we also covered a Project Zero talk talking about data-only sandbox escapes, which was a little mind-melting, but also a little inspiring. It was pretty much talking about like the Chrome renderer and escaping that with data-only, well, data-only in quotes attacks because you're dealing with JavaScript. But yeah, few really cool talks, and the ones that we'll be covering this week, this Friday, will be Attacking JavaScript Engines in 2022 by Samuel Gross and Amy. And we'll also be covering Mark Dowd's talk on how do you actually find bugs, which we referenced a little bit before, a couple episodes ago when we had a bit of a discussion around it. But yeah, I think we didn't watch the talk all the way through and just kind of talked about different points through it in that discussion. So yeah, we still want to cover it on the watch party stream. But yeah, like I said, that's all going to be on YouTube, not on Twitch, just because, we want to avoid any potential, legal issues there. And yeah, so that'll be on YouTube, and that's at 6 p.m. Eastern, 3 p.m. Pacific on Friday. All right, so we'll get into some of our topics here. First one is a news topic, and it's from the Department of Justice and their new Computer Fraud and Abuse Act policy that was put out. And Z, this is a topic that you've liked to talk about before, so I'll let you take the lead on this one.
Yeah, this is a little bit of my own little soapbox here, I guess. DOJ on Thursday put out a new policy regarding what cases they would charge under the Computer Fraud and Abuse Act. If you've listened to the podcast on the past times I've talked about CFAA, I'm not a fan of the law. It's just really vaguely written, and it's really easy to kind of enter into this sort of selective enforcement where basically just on the whims of the prosecutor or maybe some company pushing the prosecutor to actually make a charge, people will get charged or not charged, and it's not clear in the law where the line should be. It's really vague. I think last time we talked about was after a Supreme Court. It was either after the opinion or the actual ruling regarding a police officer basically exceeding or potentially exceeding access, where he was given access to a system and then was running other queries to search for people for profit or letting people pay him for it. I don't think that was publicly offering it, like anybody could pay him, but still taking money and kind of just running extra searches. And so they were pursuing that under CFAA. And it seems like this policy is kind of in response to the Supreme Court ruling out of that, where they're basically walking back how often they'll use the CFA. They do also call out right at the top here, probably inspired because of the whole incident out of Missouri with a journalist basically accessing HTML source and the governor trying to push for charges. Although, in fairness, the prosecutor did not, but they do call out here that this policy for the first time directs that good faith security research should not be charged. The fact that this hasn't been said sooner, I'm happy that they're doing this and making this change. But the chilling effect of the CFA being enforced against researchers has already happened. That happened 15, 20 years ago. So the fact that they're doing it now, great, they're too late. It has fundamentally changed how research gets approached, and it is going to take quite a while for this new policy to actually, for any hope of it kind of rewarming it all. So, I don't know, it feels like a little bit too little, too late. They call out some specific cases where they're going to enforce this policy. Some of the crazier cases where CFA could have been used, like having embellished online profile, like fictional accounts using fake information, could have been considered violations of CFAA because they'd violate terms of service, which is something that the Supreme Court did strike down or strike against. That said, this is also purely a policy. New administration, and they can change the policy. Obviously, there are ways prosecutors can get exceptions to it also, so it feels to me like they need to change the law, not just the policy of the law. Changing the policy is really just creating more of a selective enforcement environment where, they can still enforce it if they want to, if they have the right person and don't have other crimes to charge them with, they can find some vague way to apply CFA. So as much as I'm happy about it, I also think we still need to push for the law itself to be changed here. And that's the end of my rant or soapbox.
You kind of commented at the top that part of your problem with the CFAA was like how vague and non-specific it is. I feel like that kind of carries forward too in the policy that they put out. So I did kind of glance over the policy they put out. It is a lot of legalese and whatnot, but there was one quote towards the end where they're saying they said security research not conducted in good faith, for example, for the purpose of discovering security holes in devices, machines, or services in order to extort the owners of such devices might be called research, but not in good faith. CSIPs can consult with prosecutors about specific applications of this factor. So, like, there seems to be, and this is something the EFF comments on too. This concept of good faith is not really super well defined, because, like, the EFF points out a case here. Like, what if you have alternative motivations when you're doing security research? Like, say you responsibly disclose the vulnerability, but then you also talk about it at a conference, or uh, you get paid for it through like maybe ZDI or something like that. Like, you can have like alternative motivations, and does that then take you out of the good faith category? It doesn't really seem super clear. So it still kind of seems to have that same problem where it's relying on this vague definition of whether or not you fit this good faith classification or not. So yeah, I mean, it seems a little bit flimsy, just at from my understanding of it. Um, but yeah, like I wasn't even really thinking about what you brought up until you said it, with like the fact that this is a policy, like it's not like set in stone or anything, like kind of like the law is, where it's like a brick wall. And once it's set in there, it's really hard to change. Um, so yeah, I was initially maybe a little bit more hopeful than I guess you were, because yeah, I didn't really think about the policy aspect too much. But yeah, I mean, it's some good steps, but it feels a little bit too flimsy personally. So I'm curious how much this is really going to change. Um,
I
yeah.
can't imagine it's going to change a lot. I mean, I guess one of the other things that I can absolutely imagine happening is that, they call out specifically researchers, acting in good faith and trying to, or not necessarily acting in good faith and trying to extort the owners of the software. And we've talked a lot before about, if you ask about a bounty, is that going to be considered extortion? If you say like, hey, do you have a bounty program? Suddenly you're extorting them. I could absolutely see a prosecutor framing it that way because they've done bad takes around the framing before. Uh, so like good faith is, yeah, I mean, it's not really a well-defined term in general. The policy isn't law, so I'm not going to expect them to have like the same level of detail as one might expect out of the law. And even with laws, a lot of it still ends up coming down to letting the courts actually interpret it. So there are a lot of questions being left, and CFA just hasn't really been pushed all that far in terms of having like any rulings reach the Supreme Court. Like the Van Bruin case was, I think, the first time the Supreme Court heard anything about the CFAA. But yeah, I mean, I still have concerns. It's great that they're taking at least some apparent steps to protect researchers, but too little, too late, in my opinion.
And I will quickly add, I've kind of said this before when we've covered these U.S. law type topics, but part of the reason we're covering it on the podcast is yes, this is like the U.S. Department of Justice. This is U.S. law, though a lot of countries kind of look to the US for shaping their own laws, so it does have like kind of a big impact, even though it is technically only the US that this applies to. So yeah.
Yeah, good to shout that out and at least point that out. I mean, we're both Canadians talking about US law because US law has a pretty significant impact. Also, when you consider the fact that a lot of internet or tech companies are based in the US. They might have servers elsewhere, but also there's a good chance you're going to be passing through US servers and thus US jurisdiction.
Yeah. All right, so we'll get into some of our exploit topics now. So we have another Microsoft post on a macOS vulnerability. A few months ago, we covered Shrootless, and now we have Powerdir. So we're continuing the name vuln train. This is a transparency, consent, and control, or TCC bypass. TCC is yet another Apple subsystem that's a little bit vague in its naming, but Microsoft details it a bit here. Basically, it's the backbone for protecting access to privacy settings and iCloud account and stuff like that. Um, and it's protected by a policy that was introduced that would restrict access to TCC to apps that have full disk encryption. That way, it can't easily be subverted by any application. The way that TCC works is it tracks consent history for app requests, basically. So if you've previously given consent for an app to access some particular functionality or data, that'll be stored in the TCC database, and it can skip prompting for user authentication or whatever next time so that it's not so annoying. If there isn't a record present, though, it'll prompt for authorization. There's two databases used for that. There's the user database for like the user profile and a global one for the system. And this is all managed by the TCC daemon or TCCD. So anyway, Microsoft looked at some of the previous attacks on the TCC database and bypassing it. One in particular that caught their attention was the environment variable poisoning, which was a bug where TCCD would basically use the home environment variable to build up the path to figure out where the TCC database was. Um, and that kind of left the weak point because the environment can be like attacked by the attacker. So an attacker could just change the home environment variable to some arbitrary path they control and get an arbitrary database they control loaded. So that was kind of a silly bug. The way Apple fixed that was to stop evaluating the home environment variable and instead use this get pwuid function to get the working directory field or the pwdir field, which has the user's home directory. And Microsoft points out that while that fix works and in a way because it fixes the ability to manipulate the environment variable for an easy bypass, the core issue still remains, being the fact that it relies on the user's home directory at all. The user could end up changing their home directory. So that's kind of what they explore here is the different vectors to do that. Their first POC of this was using the directory services utility to change the home directory to a temporary one. That worked, though it did require root access, and it required it had to be invoked with an app with the TCC policy, which I think was DS export and DS import in this case. Um, and yeah, like you still need root, though I think this is still technically a privesc because you're able to get a fake database loaded without full disk access. So I think even if you have root, TCC is still meant to like act as a security boundary. Um, that technique ended up getting killed due to Apple changes on DS import, and so they came up with a second POC, which was the config daemon for system configuration. It turned out that daemon also had the TCC entitlement to allow the home directory to be changed, and you could get arbitrary code loaded using the bundle option. So that one was even more powerful than the first POC they tried. But yeah, I mean, the main problem with like their the vulnerability here is just the fact that they rely on the home directory for using the user database, and that could be changed by an attacker potentially. So yeah, I mean, it's a bit of an interesting logic bug, um, though the impact is quite neutered there. Where at least the vectors they showed here would require root. There might be some other ones that don't. Um, I'm not totally sure. You'd have to like play around and do a lot of searching. I would I would think that Microsoft probably would have found them if they were easy, or if there was like a blatantly obvious one. But yeah, at least from the techniques they showed in this post, it requires root. But yeah, I think that's still bypassing a security boundary, so it's still like worthy of calling out.
Yeah, and I mean, modifying the home directory and building off of that is just a good kind of trick to be aware of in general when looking at desktop applications. And looking for any sort of privask. Um, Plenty of applications will do that. They'll store some user specific data in like a dot folder underneath the home directory or something, which you might be able to manipulate by controlling home. So like I also think just that very first trick is worth being aware of if you're going to be doing any sort of bug hunting against those desktop services or even just normal desktop applications. Maybe to abuse that depending on the scenario. But yeah, I mean, needing root definitely neuters it a bit. Um, Technically, it's a privask, but not by much, really.
It's a
Um,
high ask.
yeah, yeah. If you're
Yeah.
already there are probably other routes too. But defense in depth. I mean, might as well fix one if you can. But I mean, I get the reasoning beyond just leaving it at that. And yeah, if there were any obvious non-root routes, I would have expected them to call them out here. So I mean, yeah, I can't think of anything. Usually, changing home directory is not going to be something that the user themselves gets control of. So yeah, I mean,
Yeah, exactly.
still interesting vulnerabilities, and I always kind of like covering some of these vulns that aren't just our standard web app issues, because I think a lot of people maybe avoid testing like the more desktop services because they don't know what type vulnerabilities to be looking for. So at least a little bit of exposure.
Yeah. All right, so we have some HackerOne reports in the show today. Our first HackerOne report is one to GitLab, and it's a sort of XSS bug in Jupyter notebooks, though it's a little bit interesting, which we'll get into there. It's based on GitLab's use of Rails UGS or unobtrusive JavaScript, specifically the fact that arbitrary data parameters outside of UJS's known attributes like data URL and data method won't get stripped out by DOM Purify. They will be sanitized, but they won't be stripped, and that kind of leads to an issue due to how GitLab has their pages set up here. And it ultimately leads to like a clickjacking type attack to get a victim to send an arbitrary post request. What they focus on for attacking this here is this dismiss event handler that gets called and attached to elements with the close button class. Um, and this dismiss event handler will decide where to post the user using the dismiss endpoint. And the problem there is that can be set with the data dismiss endpoint attribute. And because this attribute can be attacker controlled and it's not being stripped out by DOM Purify, all they have to do is get the user to click a close button element and they can post the user wherever they want, which they do by using an output in Jupyter Notebook that'll create a button that spans the entire page with a close button class. They talk how this could be used in a few different ways in the initial report. The first was a bit harmless with just adding a to-do on an issue in one of the researchers' projects. The other was a payload that demonstrated abusing the GitLab API to use GitLab's user creation to add an attacker as an admin user. Another thing that was demonstrated was adding an SSH key to any user through the API as well. So really, there's a lot of avenues that could potentially go there. You're basically abusing the API and doing clickjacking to do anything that the admin user could do. Um, but yeah, I mean, kind of an interesting report because it is somewhat like an XSS type issue, but like the what's being passed in is being sanitized by DOM Purify. It's just not enough because the attacker just needs to be able to control some of those data attributes that are being used. They don't need to like break out of it and you know go your more typical XSS route. So yeah, because this is or does potentially have some high impact. They awarded the $8,600 or 690 bounty. So yeah, pretty high bounty payout. Um, yeah, bit of an interesting issue just in terms of like how it was exploited and abusing like DOM Purify's lack of stripping there. It's kind of a cool bug.
Yeah, it's definitely like, it's a nice little chain of, I mean, not even a chain, but just taking advantage of what normally wouldn't be a hugely significant issue. Just that ability to get things into the data attribute. Taking advantage of that, turning it into something that does have pretty significant security considerations. So I mean, I thought it was interesting on that front. You do call it kind of like clickjacking. I get where you're coming from, although I will at least just mention, like, for it to actually be clickjacking, that would require kind of framing the page and posting this outside, whereas it's more just the uh it's actually a little bit of a XSS technique where if you can't just run arbitrary code, but you can get it, say, on an on-click event, you create like a button that takes the whole page. They can't see as long as they interact with the page, they'll get your JavaScript running. Kind of in that vein, I totally see where you're coming from with calling it kind of like clickjacking, because with clickjacking, you're often trying to create like a big target area somebody can click on and kind of doing some similar tricks. But figure I'd at least call out it's not quite clickjacking in this case. It's more of an abuse, almost like a HTML injection. Although, yeah, I mean, I guess they even call it here as HTML injection.
Yeah,
Still a cool issue.
yeah, it's just kind of borrowing the similar techniques to like clickjacking. So
Yeah.
all right. So our next HackerOne report was a bit of a funny issue that was reported to Glovo, which is like a delivery platform where you can order things and have them delivered. Kind of functions like a marketplace and allows kind of deals with like the payments and totaling up the order. So, and that's where this bug comes into play. The bug here is an int overflow in the quantity parameter of the post request for the order, which can affect the total price of the order. Unfortunately, the summary doesn't really do a super good job of covering what the issue is. They have like all of these sentences and paragraphs covering what an integer overflow is, but then they don't really talk about what the problem is. You can kind of figure it out though through the screenshots. There's lots of screenshots to go through here. Screenshot 167 kind of demonstrates it pretty well. So basically, what they do, they intercept the post request of the order, um, and then they edit they order two different types of products for delivery, and they change the quantities to like 22,99922 and 24,99999, which when that gets used to calculate the price ends up overflowing, and it would ask for a total of like 10 BAM when it should be like obviously a lot more than that. Um, so yeah, I mean, kind of a funny issue. I don't really know how well this would work out in practice because I feel like if you were like a vendor or something and you saw somebody ordering that many, like a quantity that high of an item, you would probably be a little bit suspicious, and you would
Well,
probably look at the order total and see, oh, that doesn't really make sense.
yeah, and kind of
Um,
the ability to fulfill such an order, which is kind of the interesting thing. So they did actually, one of the pictures here is like the guy with the delivery person. Something got delivered. So what I really find lacking in this report is they don't show what was delivered, because this order is like 5.75 million gallons of hair conditioner. I don't think that guy delivered that much hair conditioner in like
it'd be a
30
little
minutes.
difficult. Yeah.
Like, and that's the other thing. This is like a 30-minute turnaround on the order. So like I could imagine some automated system slipping through, but if he got more than what he paid for, huge issue. But it's not clear if he did or if it actually only sent him like one of each item or something. Like, it's a really funny issue to see here, but I wish he'd have been clear about what he actually got delivered and what he actually got out of it. Because it feels like the fact that he didn't include that and the fact this is such an impossible order, he might not have received enough, or perhaps they only sent like what they had in stock and he got it for really cheap. Like, there's a lot of ways it could have played out that aren't indicated anywhere, which I find really strange that it's not mentioned anywhere.
Yeah, it's unfortunate. We can only be left to speculate, but yeah, I mostly just wanted to cover this because it is like a really funny bug and a really stupid bug,
Yeah,
um,
it's great. Like, I
despite the
could
lack
just
of detail.
imagine the poor delivery guy, like, actually needing to deliver, like, just this insane amount of anything.
Yeah, that would be a bad day. All right, so we'll get into our next topic here, which is a post on stealing Google Drive OAuth tokens from Dropbox, which is inspired by a topic we covered a few months ago, actually, which was hacking Google Drive integrations. Z, I'll let you take this one.
Yeah, we covered another post a while back where it was, hacking Google Drive integrations, and that was on our, I think, February 8th, or at least the week of February 8th. That's the number sticking in my head here that we covered. And the idea there was with the Google Drive API. I'll even pull up our old summary for it. Um, Effectively, you would have when you'd make the request trying to get like what download URL for a file or whatever, you'd normally get this JSON response that has the download URL in it. But what you could do is if you could include in the URL the alt equals media, basically telling Google Drive to grab the actual file content. So alt equals media, you're going to display the media rather than the meta information that would normally come. If you had a file on the Google Drive that was sorry, I'm confusing myself a little bit, but if you had a file on the Google Drive that was JSON content and included its own download URL, you would basically get an SSRF because the application thinks it's making a request for this meta information and then following the download URL to get the file, whereas you're actually controlling what URL it's going to try and download the file from. So Dropbox ended up patching this, or HelloSign patched this by blacklisting sensitive URLs. So basically not preventing the SSRF, but preventing it from being used for anything like the metadata service or anything useful like that. Problem with that is of course the SSRF still remains. Granted, it is a case of a file or sorry, of an attacker kind of attacking themselves because it's going to be used. Or one other detail about this that I neglected to mention is when it goes to download the file, it's going to include the Google Drive authorization header. It's going to send like um, information about the integration or like what OAuth account is connected to. It's going to send that header with this request. So it's basically the attacker attacking themselves because that authorization header is going to be like for their integration. So what they did here on the second one, because they left the SSRF in after patching this, leaving the SSRF just can't get metadata, they changed it with a CSRF. Effectively, the request to cause this SSRF wasn't protected by any sort of CSRF protection. Therefore, they can get a victim to basically access their HelloSign link, and that link would end up causing the request to happen with their victim's authorization header or authorization token, which would then basically let them leak it. So just another way of abusing that same issue, which I am a little bit surprised that the patch did go kind of this route of just blocking it rather than blocking the core issue of having this SRF at all. um, Given that partial patch, like I'm not surprised somebody found a way around it.
Yeah, just kind of cool to see a follow up to like that earlier research, because I think they call out like that caught their attention and they started looking at that. Sorry, I just had to step away for a few minutes, so I might say something that you already covered, but um, yeah, I mean, like you were saying at the top, the VOD for when we covered this earlier report was mentioned on the February 7th episode. So yeah, you can go back and check that out if you're interested. Timestamps are in the description. But yeah, bit of a cool chain and
It's a
um,
cool bug. Like, I mean, this bug on a whole, I do think we
mhm.
are going to see pop up a little bit more. Somebody calls it out, and then people start looking for it elsewhere. I can't imagine that Dropbox is the only place where you can get that alt media in there, and like having the core vulnerability, having that pop up elsewhere. I can easily see happen.
Yeah. With that said, that's basically all the exploit topics we have. I do have one shout out that I want to mention before we wrap up the show. And it's a research post from Google's security blog about Kubernetes and privileged pod escalations. Not really a ton in here. It basically just documents some of the changes that Google has made, and the improvements they made to GKE security, as well as some tips developers can apply to reduce the likelihood of privilege escalations. This is kind of coming off the back of a presentation at KubeCon, where Palo Alto Networks demonstrated using trampoline pods, as they call them, or basically pods with elevated privileges to, escalate and take things further, which we've seen in cloud quite a bit. They stayed up front like these attacks are somewhat unlikely and had some major prerequisites, being that an attacker would have to compromise and break out of the container. But yeah, they have some like suggestions for developers to follow, which is like using GKE Sandbox, using autopilot, which deploys some default policies and stuff like that. And also some of the steps that Google are taking. So like they're adding an admission controller to autopilot. They also made a permission scanning tool that can like identify pods that are super privileged, and they use that to assist in like their audits. So yeah, like I said, nothing super technical there, but I wanted to bring it up because we've covered some container escapes before and talked about these types of issues. And these privileged pods or containers are a very useful privesk route, but they're also a necessary evil as they're needed to perform some of the actions that are happening in the setup. So yeah, this kind of explores that and some of the steps that are being taken. So yeah, it might be interesting to some people out there who are doing that kind of research. But yeah, with that said, that's basically everything that we have for this week. Um, so yeah, we'll wrap up the show there. Thank you everyone for joining us. Links for our Discord and Twitter and such can be found on our site or in the chat. We always welcome people to the Discord. We have some cool discussions in there. You can also find summaries and VODs for our previous episodes on our website and on the YouTube. We'll be back for binary topics tomorrow at 7 p.m. Eastern, 4 p.m. Pacific. And once again, we'll also be live on YouTube on Friday night at 6 p.m. Eastern, 3 p.m. Pacific for a watch party of a few more offensive con talks, being attacking JavaScript engines in 2022, as well as how do you actually find bugs talk. So yeah, we'll hope to see you there. And other than that, take care.